Now let us take the another topic, that is magnetic effect of current. And this topic, as you know, the name of the chapter suggesting what magnetic effects of electric current. So this is the prominent topic of this chapter, and this is going to lead us how the current is producing magnetic field. Okay, so earlier it was discovered by Hans Ørsted Kirchhoff. Okay, so what he has delivered, he has seen while doing an experiment that a circuit and the current passing through the circuit is deflecting the magnet compass which is putting nearby to it. Okay, so the current here is deflecting the compass needle. That is how. So he experimented that thing, and what he has learned like this. Okay, he has firstly put in this kind of circuit, and he was doing some experiment on the current behavior and different ways for the resistance also. Okay, and the compass and which is put it here like nearby to it. So when he was switching on the circuit, what is happening here? The needle of the compass get deflected. Okay, so now he was surprised that it is deflecting the magnetic compass. That means electricity must have the property of magnetic effects. That is why it is affecting this. Now what he has done in the next thing, he has reversed the current. How? Just putting the battery direction in different way. Like earlier, it was going from plus to minus like this, and he has just changed the direction of the battery now. So now he sees that when the battery current has been changed into different direction, so the deflection of the magnetic compass needle is also get changed. Okay, so इसका मतलब current change हो रहा है, तो magnetic field भी change हो रही है. Okay, and according to that, the direction of the needle is get changed. But this is not like this when we kept on the battery and kept on the circuit for a long time. So it is kept on deflecting. It just deflect when this going to be switched on and switched off. Okay, so this was one of the prominent thing that he has observed at the time when he keeping on the circuit, like just on ही किया है, then it is getting deflect, and when it is taking it off, okay, जैसे ही बंद किया तब वो deflect हो रहा था. When on रखने के बाद में जब वो थोड़ी देर उसको रखता है, then it is not deflecting. Okay, so change in current is producing here. We can say that change in current, because earlier in current it was not when we switched off the circuit. So this get an idea that no current is flowing here, and when we keep it on, so that means from 0 to certain current limit is going on. So that is producing a magnetic effect here. Okay, so that means when the current is going to change from somewhere, so magnetic property somehow increases, and it is because of the electricity that is flowing inside the circuit. So this shows us that electricity produces magnetic effects. So here we can say that I is directly proportional to B, or B is directly proportional to I, vice versa, because here I means current and B means magnetic field. So current is producing magnetic field, more the current, more the magnetic field, and current value should be changed. Okay, from 0 to something. So if the value that is going to be high, like if we are changing it from 0 to 2, okay, ampere. So this is a less current, let's suppose, and 0 to 5. So which condition will become the more magnetic field? Okay, so in the second condition we will get more magnetic field. So what conclusions we have drawn from all these things? This experiment shows us that the deflection of compass needle was due to magnetic field produced by the electric current. That is sure that I is directly proportional to B. Okay, and second conclusion we have drawn from the experiment is any change in the direction of the current will also variation in the deflection, because when we are kept the battery from positive to negative, it was deflecting like this, and when we change the direction of the battery, negative and positive like this, now current will flow from positive to negative like this, so it will changing the direction of the compass needle also.